Okay students, so I will describe you the basic setup that you use for capacitance measurement and variation of capacitance with respect to frequency and temperature. So in this session we will only be doing the temperature variation, we won't be doing the frequency variation, but I will describe you the setup, the full setup. So this one is your controller for the frequency, okay, and this one is your CRO's typical cathode ray oscilloscope. So this is a digital oscilloscope, so we need this for signal. This frequency controller actually gives you can use it to measure the capacitance, unknown capacitance, and the way it does it is called a Soumyendu bridge, which is an adaptation of Wheatstone bridge, which you might have studied in your +2 and in your electronics courses as well. So it's an adaptation that is used to measure an unknown capacitance. Okay, so you can find the more details in the manual that is uploaded in the LMS. So so this is your frequency controller, and this setup is also the setup that you will be using to measure your unknown capacitance. And for measurement of that capacitance, you have to display the signal, output signal from this Soumyendu bridge via this oscilloscope. Alright. This one is your temperature controller. Okay, this entire setup is your temperature controller and temperature measurement setup. So both of these things is done via this setup. This one, what you see is basically the 2-probe arrangement, where you will be basically putting your capacitor and doing the measurement. So you have electrical connections which you take out from here, which also has the temperature sensor as well. So we'll connect the temperature sensor to here, capacitance measurement to this one. Alright, so you see there are these two rods, these two big cylindrical rods. So these are your probes, these are your electrical connections. Okay, so they are called spring loaded probes. What do you mean by that? Is basically, if you are able to see the bottom here, so if I pull them up, so they have a spring, so I release them and they get proper connection, proper metallic connection by the action of the spring. So basically we'll put our capacitor between these two probes, okay, at the bottom there. Then we will take the whole thing and we will put it inside something called a oven. So this is like a miniature oven, and where we will take our samples and connect them and then put them inside this oven. Okay, and then take out the connections and make the connections with the rest of the instruments here. So this oven maintains a uniform temperature. So the temperature sensor is also just below the sample actually, in this probe setup only. So if you take a look at the probe setup, there is a insulating sheet here, very thin insulating sheet, and your sample will be between these two rods. Just below this sheet, just below these two rods, there is a temperature sensor, okay, which basically takes the data out and gives the temperature of that sample. Alright, so this oven maintains the temperature, and this is the controller for the temperature as well as the temperature sensor. It gives both of your data. You can set a particular temperature and it will go and create that temperature. So we'll describe the experiment later on, but for the time being, I was just telling you what are the different components of the setups here. The last bit is your capacitor. So there are 2-3 different types of capacitors, but the experiment we will be doing is with barium titanate based capacitors. So you see this is a sample holder. There is a sort of an arrangement to form an electrical connection to, if I, for example, this is my capacitor, this simple disc like thing is basically my capacitor. Okay, so it has a barium titanate film, a thick film for barium titanate, disc like barium titanate film, and both sides are coated with copper. Okay, sort of a micrometer, few hundred micrometer copper. So you can place it on top of this one, okay, on your sample holder. So you see the bottom electrode is connected now. So once you place this disc, so the bottom electrode will be connected to this, and it will be you can take out the connection from here. So you can tube your probe here. So your capacitor will be like this, and your probe will be connected to this one. So that will be a connection for the bottom edge. The top edge you can directly connect to the top electrode of the barium titanate capacitor. Alright, so this is the basic setup so that we will be using. So next I will describe you how we do the measurements. Thank you.